Concepts related to the hydrologic cycle have to do with the location and movement of water on the Earth that is characterized by the hydrologic cycle. Water is contained within atmospheric moisture regime, the surface moisture regime, and the subsurface moisture regime. The subsurface regime can be divided into that moisture which is in soil, immediately adjacent to the surface of the Earth, and that moisture which is contained within groundwater in geologic material, which can be either unconsolidated material or consolidated bedrock. The hydrologic cycle is characterized by three separate moisture regimes: the atmospheric moisture regime, the surface moisture regime, and the subsurface moisture regime. So these three moisture regimes characterize the notion of the hydrologic cycle. There are water flows within each of these regimes. Within the atmospheric regime, we have advection, or the horizontal movement of atmospheric moisture by wind, and we have vertical movement of moisture by atmospheric pressure gradients, where the moisture is moving up and down in the atmosphere, versus advection, where the moisture is moving horizontally. We also have flow within the surface regime, where we have overland flow. This is water flowing directly across the surface of the land. And then so-called channelized stream flow, which is water that's flowing in some kind of an organized stream flow, some kind of an organized channel. And then finally we have the subsurface regime, and we can talk about that as the subsurface flow of soil moisture and groundwater flow in underlying geologic structure. So again, we can talk about the movement of water within the atmospheric realm, where we have advection moving moving air masses containing moisture horizontally, and then we have air masses moving vertically that are displacing water vertically within the atmospheric moisture regime. On the surface moisture regime, we have overland flow, water moving directly across the surface of the land, and we have stream flow, water moving in stream channels. And in the groundwater regime, we have water moving as subsurface soil moisture flowing horizontally and vertically, and also groundwater flowing horizontally and vertically. Water flows between these regimes. We can talk about water flowing from the atmosphere to the surface regime through the effects of precipitation, rain and snow, where moisture is falling out of the atmosphere, sometimes moving up, but generally speaking, moving down, transferring from the atmospheric regime to the surface regime. Then we can talk about evaporation of surface moisture, where water is going the opposite direction from the surface regime to the atmospheric regime, where streams and ponds and lakes, surface water from those water bodies is evaporating into the atmosphere. We have transpiration of plant moisture, where plants on the surface of the Earth are transpiring moisture back into the atmosphere. And then we have something called sublimation. Sublimation is the direct transfer of water from a liquid or from a solid or ice state into a gaseous state. Within transfers from surface to subsurface regimes, we have infiltration into the subsurface from the surface regime, and we have discharge into the surface regime of soil moisture. Similarly, in the subsurface regime, we have water percolating from the surface down into soil moisture, and from soil moisture down into groundwater. And then we have discharge from groundwater to both subsurface and to the surface water regime. So going back to our diagram, then we can see there is water being transferred from the atmospheric regime to the surface regime by the effects of precipitation, rain, snow, and then there is also transfer from the surface regime to the atmospheric regime through evapotranspiration, the evaporation of surface water and transpiration of plant moisture, through the sublimation of snow from a solid state directly to a liquid state. Then we have movement of water into the into soil moisture, and from soil moisture down into groundwater flow. We have discharge from soil moisture into surface water bodies, and we have discharge of groundwater flow back into soil moisture, and we have discharge of groundwater flow into surface flow. So we have multiple types of water within the landscape based upon whether we're talking about the atmospheric moisture regime, the surface moisture regime, or the subsurface moisture regime. And we have multiple transfers of water from each of those regimes to another. We can think of the hydrologic cycle as a hydrologic equation wherein the amount of precipitation that is received is going to be equal to the amount of surface runoff that we have, that is, the amount of water that runs off directly across the surface of the land, the evaporation that happens, the transpiration and the sublimation, the movement of water from the surface regime into the atmospheric regime, the change in surface runoff water storage, how much water is contained within streams, lakes, and other water bodies, the change in soil moisture that's contained, the change in moisture that's contained in the soil moisture regime, and then finally a change in the amount of water that's stored in groundwater. Hydrologic structure of surface regime can be characterized as being of two types. First is what we call intermittent flow versus perennial flow. Surface runoff is fed by intercepted precipitation flowing directly in the stream channel. This is rainfall that flows directly into the stream channel itself. It's affected by intermittent flow channels fed by precipitation, overland flow, and subsurface flow alone. And when there is insufficient amount of precipitation, overland flow, or subsurface storm flow, the intermittent streams will stop flowing. And then we have streams that are perennially flowing. These are streams that are fed by precipitation, overland flow, subsurface flow, but also fed by base flow discharge from the groundwater regime. As I mentioned earlier, well over 3/4 of the water of the drinkable water is contained within groundwater, and there is often a significant amount of discharge between groundwater regime and surface water regime, which is what keeps streams flowing on a perennial basis, year-round perennial basis.